In science and engineering, we do a lot of unit conversions. And that can be a little tricky, so I wanted to make a few videos hopefully simplifying that. And I wanted to start by exploring the idea that any number to the power of 0 is 1. And of course, whenever I say power of, I mean make it an exponent. So let's start with 10. Let's explore the idea of 10 and its exponent. So 10 to the power of 0, just like every other number in existence, is just 1. And so let's compare that to other exponents. So what about 10 to the power of 1? What does that equal? And while we're at it, let's explore, what does 10 to the power of negative 1 equal? And let's continue down this sort of pattern. Let's look at 10 to the negative 2, and let's look at 10 to the positive 2. Let's look at what each number is. And so let's start simple. Let's look at 10 to the power of 1. Well, that's obviously just 10. So that's pretty easy. And 10 squared is 10 times 10, so that's 100. So that's pretty easy. But what about when we take 10 to the negative 1 power? So to figure this one out, I'm going to pull out my handy-dandy calculator. I'm going to take it to the negative 1 power. So to do that, I'm going to hit this button right here. That's going to give me an exponent. I'm going to say to the negative 1 power. And what do we get? We get 0.1. So 0.1. And what happens when we take 10 to the negative 2 power? So I'm going to do the same thing again. I'm going to raise 10 to the power of, and this time I'm going to type in negative 2. And what do we get? We get 0.01. So 0.01. So before we move on with this pattern, let's explore what's going on. When we take it to the negative 1 power, it moves this decimal from 10 to the 0 power, from 10 to the negative 1, to the left one place. And so we get the decimal right here in front of 1. And likewise, when we take it to the second negative exponent, we moved it 2 places to here. And then if you look, what happened when we took it to the positive 1? Well, that moved that decimal to the right 1 place. And when we took it to the positive 2, we moved this decimal to the right 2 places. So if we look at 10 to the third power, we'd actually get a decimal moved over 1 more place, and so we'd get 1,000. And likewise, if we did 10 to the negative 3, well, what will we get? We take this decimal place and we'd move it 3 places to the left, so 1, 2, 3, and we'd get a 0.001. So a certain way to look at it is that 10 to the 0 is the standard, it's 1, and each time we change it, if we move 0 up to 10 to the 1 or 10 to the 2, it just moves that decimal that direction. If we do negative 1, then we move the decimal to the left instead of the right, but it moves the same amount depending on what our exponent is. And of course, another way to think about it is what these exponents could mean is, when you're using 10 anyway, is it's how many zeros you have. So 10 squared has 2 zeros. 10 to the first power has 1 0. 10 to the third power has 3 zeros. 10 to the 0 power has 0 zeros. And likewise, if you look at it, so do our negative ones. We have negative 1, or to the negative 1 exponent gives us 1 0. To the negative 2 exponent gives us 2 zeros. But this trick only works if you consider the 0 before the decimal. But it is a cool little trick that we can apply. We could say, well, what's 10 to the 6th power? Well, we wouldn't have to do anything. We could just count out how many zeros there are. And it would be 1 million, because 1 million has 6 zeros. And we can do the exact same thing for 10 to the 9th. What do we get? Well, we just write 1, and then we'd write out 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so 10 to the 9th is the same as saying a billion. And then we could do the same thing over here. We could say 10 to the negative 6. Well, we can rewrite this as 0.0. So we got 2 zeros, 3, 4, 5, 6, 1. And then we can do the exact same thing one more time for 10 to the negative 9th. We could just count out 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a 1. And if you've ever wondered why we do scientific notation where we say something times 10 to the negative 9, so we said 5 times 10 to the negative 9, for example, whenever we do that scientific notation, it's because 10 to the negative 9 is easier to say and easier to write out than 0.000000001. Even just now, saying it was exhausting for me, and I'm sure it was even more exhausting for you to have to listen to me. It's a lot easier to just say 10 to the negative 9. And so that's why we have these values. And in fact, if you look in your formula sheet, you actually have this chart that we've made, except it goes a little bit more in detail. It goes all the way to the 24th and the or negative 24th and the positive 24th. And I won't bore you with that. You can explore that on your own. This video is just sort of teaching you how to read that chart and how to use it. So for example, in that chart, it has all the prefixes before each individual unit. So prefixes are great because you can use them for anything. You can use them for bytes, you can use them for meters, you can use them for liters, you can use them for anything. And so we could say 10 to the 0 is just a regular byte. If we were going to use bytes, for example, then we can go up. We could say this, or we'll start at 10 to the third. We'll say this is a kilo. So if we're talking about bytes or meters or liters, we could say kiloliters or kilometers or kilobytes. That's what 10 to the third is. It's 1,000 of them. And I like to use bytes because it works so well. We know these so well. We know 1,000 kilobytes, hopefully you know anyway, is a megabyte. And that is the term for a million, or 10 to the sixth. And then 1,000 megabytes or 1,000 megameters or 1,000 megaliters or anything you're using is, of course, a giga for that. And this works for any type of unit. And some that are less commonly used that you should probably know, though, or at least I want you to be somewhat aware of, is deca and hecto, which are just the prefixes for these, which just are not used that commonly. And then we can do the same thing over here. We could say this is deci, which again is not that common. But this one is, 1/100th is centi. And then, of course, moving the decimal place 3 places is a milli. So we've seen these before, like millimeters and centimeters and whatnot. But as we get smaller, it might be a little less common. You might know this, you might not. But 10 to the negative sixth is micro, which is 1/1,000,000th. And then 10 to the negative 9 is 1/1,000,000,000th, or nano. So that might be a nanometer or a nanobyte. Or if you watch Avengers, nanobots. But one of the cool things about this chart is we can say that 1 decameter is equal to 10 regular meters, or 1 decabytes is equal to 10 regular bytes, or a more common way to put it is 1 kilometer is 1,000 regular meters, or 1 kilobyte is 1,000 bytes, and so on and so forth. So we can say 1 mega is equal to 10 to the sixth, or a million regular, or 1 giga is equal to 10 to the ninth, or a billion of whatever we're talking about, whether it's bytes or meters or whatever. So 1 hecto is equal to 100 of whatever we're talking about. 1 deci is 0.01 meters, so 1 decimeter. That's less common than 1 centimeter, let's say, which is 0.01 meters. 1 millimeter is, let me write that a little bit better there. 1 millimeter is equal to 10 to the negative third, or 0.001 meters, and so on and so forth, which is why I like this chart in your notebook so much, because of all of its practical applications. And I know I've dragged on about those practical applications in this video, but the last two thoughts I want to leave you with is, first off, if I were to change this number here, 2 nano, this would become 10, or times 10 to the negative 9, so 2 times 10 to the negative 9 would give us a 2 here. So nothing would change except for we'd make that a 2. And so the same would happen with any number. So if I put a 3 here, that would just make this a 3 here, and so on and so forth. So we could do the same thing here. We could put a 5 here, and that would put a 5 here. So that wouldn't change it much. Which brings me to my very last point that I'd like to make in this video. The main thing I want to drive home is 10 to a power. Just basically, taking 10 to a power just moves the decimal that many places in that direction.